Hello everyone, my name is Sumtalan. Today I'll show you how to calculate K factor or erodibility factor of soil using Williams equation and FAO soil. As you see from here, this is the Williams equation which is developed in 1995. And in the Williams equation we have four fractions. The first fraction stands for coarse sand contents, and the second fraction stands for clay to silt ratios, and the third fraction stands for organic carbon content, and the last fraction stands for sand content. So if someone has all these four fractions, he or she can calculate the K factor or erodibility factor of any soil using the Williams equation. But in order to have these all four fractions, you need to employ these formulas. There is a formula for each fractions, but in order to use the above formulas, you need to have all these things, which is percent of sand content, percent of silt content, percent of clay content, and percent of organic carbon content. So if you have all these things, you can use this formula in order to calculate each fractions. So today I'll show you how to calculate the K factor or erodibility factor of soil using the Williams equation and the FAO soil. So in order to do that, you have to follow the following procedures. The first step is you have to download the FAO soil from internet. You can freely get it from internet. Then after doing that, open your ArcMap software. If you don't have ArcMap in your computer, you have to install. Then open your ArcMap, then bring the shapefile of your watershed and bring the shapefile of FAO soil. I have already downloaded the FAO soil. Then I'll bring the shapefile. This is the shapefile of FAO soil. Then the next thing we are going to do is we are going to extract the FAO soil for our watershed. So in order to do that, go to Art Toolbox, then go to Analysis Tools, expand that and go to Extract, expand that and double click on Clip, then bring here the FAO soil, bring here the shapefile of your watershed and give it the output raster, not output raster, output vector. FAO, let me call it sub basin. Okay, now we are extracting the FAO soil for our watershed. Okay, the process is completed. Close this one, remove this one, remove this one as well, and zoom to layer. So these are the soils in our watershed. These are the FAO soils in our watershed. Go back to your watershed shapefile and open the attribute table. So as you see in the fifth column, you will see the code for the soil. We have 3 soil. So these are the codes of the soil. So keep in mind about the soils and minimize this one and go back to FAO soil. Open the folder. Then look for an Excel sheet with the name of generalized SU info. So this is the file. Open it. Then this is our Excel sheet. Then our first soil is NE. Come here, Control F, type NE, find. So this is the first soil. Copy this one, open a new Excel sheet, then paste it here. The second soil is RE. Before typing the next soil, click on Escape, then type RE and find. So this is the second soil. Copy it, paste it here. Then the third soil is pH. Go back to FAO, escape. I think it is RH. Let me check it. BH. Then find this is the sort soil. Copy this one, paste it here. Then finally close this one, go back to the title row, copy the title row, paste it here. Then close this one, we don't need it. So after doing this, one thing I want to tell you is when we calculate the fractions, we only calculate for the top soil cover of the watershed, because the raindrop energy only affects the top soil cover. So that's why we are going to calculate all the fractions for top soil cover. So keep in mind that here we have two parts of the soil, the top part and the subsoil parts. So now we are going to ignore the subsoil, because as I've told you before, raindrop energy only affects the topsoil. So we only consider the topsoil. So mark the topsoils: sand topsoil, silt topsoil, clay topsoil, organic matter topsoil. Then delete the remaining columns. Delete. So here we have percent of sand content, percent of silt content, percent of clay content, as well as percent of organic carbon content. So as I've told you before, if you have all these things, you can use this formula in order to calculate all the fractions. So here we have everything. So the next thing is we are going to calculate all the fractions. Minimize this one as well. Then write here the first fraction, F C sand. The second fraction is F clay silt ratios. The third one is F organic carbon content, and the last one is Fi sand. Then in order to calculate each fraction, we have to use these formulas. So in order to calculate the first fraction, you have to employ this formula. Click here, equal sign, then open bracket, 0.2 plus 0.3 times exponential. In order to write exponential, type exp, then you'll get exponential. Double click on that, then minus 0.256 times MSS, percent of sand content. Here we have percent of sand content, times open bracket 1 minus M silt is a percent of silt content. Click here, divided by 100. Close the bracket, then close the bracket again. We need one more bracket, then hit enter. So this is the first fraction for the first soil. So in order to get for all soils, simply double click here. Then in order to calculate the second fraction, use this formula. The second formula. Type equal sign, then M silt. M silt is percent of silt content, divided by MC is a percent of clay content plus percent of silt content. Then close this bracket, add another bracket here, because we need to add a power. There is power of 0.3, so shift in the 6, you'll get a power sign, then 0.3, click enter. This is the second fraction, then double click in order to get for all. Then the third one, open bracket 1 minus 0.0256 times percent of organic carbon content divided by open bracket percent of organic carbon plus exp 372 minus 295 times organic carbon contents, close the bracket, then close this bracket again. 1 2 3 4, we need 3 more brackets here, then hit enter. So this is the third fraction. Double click in order to get for all. In order to calculate the last fraction, use the last formula. Open bracket 1 minus 0.7 times open bracket 1 minus ms percent of sand divided by 100, close the bracket, and divided by open bracket, open another bracket 1 minus percent of sand content. Sorry, here we need to see so, then percent of sand content divided by 100, close the bracket, plus exp exponential minus 5.51 plus 22.9 times open bracket 1 minus ms percent of sand content divided by 100, close the bracket. Then let me check whether I wrote the formula correctly. 1 minus 0.7 times divided by plus exponential 5.22, then add 1 2, add 3 brackets more, then hit enter. So this is the last fraction. Double click in order to get for all. So here we have all the fractions. So the remaining thing is we need to calculate the k factor. So if you have all the fractions, it is simple to calculate the k factor. So in order to calculate the k factor, use this formula. So k factor is a multiple of all the fractions. So equal sign this multiplied by this multiplied by this multiplied by this, you will get the k factor. Then double click here. So copy this one, paste values only, then go back to ArcMap, add a new field, name it k factor, then type float, OK, and go to editor, start editing, then copy this one, paste it here, copy this one, paste it here, copy this one, paste it here, and then go back to editor and save editing, then close this one, go to your shapefile of your watershed, right click in the properties, go to symbology, categorize, value field, k factor, add all values, apply. Okay, so this is the key factor for our watershed. So you can calculate the key factor by doing the same. If you like this video, please subscribe my channel. Bye.